Hi, this is Julia Walker with Grey Duck Forge, and today we're going to be talking about the anatomy of synovial joints from a farrier's perspective. We'll be going over all the main structures involved, looking at a couple diagrams, and hopefully learning a thing or two about joints along the way. If you're new here, in short, I make videos going over the main topics that come up on certification exams for farriers. The goal is to make helpful study tools, whether you're just starting out in school or studying for the journeyman exam. And if you're not a farrier but are just here to learn, that's totally okay too. I'm really just hoping to make this material a little easier to learn for everyone, hopefully without making any factual errors along the way. So with all that under our belts, let's jump into this joint anatomy business. So what's in a synovial joint? There are 6 main structures to be familiar with. We'll go over the important ones individually as we go, like for example, hopefully you already know what a bone is. If not, good luck. But this is everything that is involved in a synovial joint. And here we have a color-coded diagram of every structure you should know. You're welcome to screenshot this and save it for later to make sure you can label the structures on your own. But to walk you through covering the ends of both bones of the joint, we have the articular cartilage. Then between the bones and their cartilage, cushioning things and reducing friction, we have that synovial fluid. Generating that fluid, there is the synovial membrane on the inside of the kind of joint capsule. And then just outside of that, holding everything in and providing some structure, we have the capsular ligament in that dark green there. And then lastly, making up the outermost part of a joint are the 2 collateral ligaments. In red there. Cool. And if you can label this from memory, you're in good shape. We'll talk about the capsular ligament and the synovial membrane on its inside edge first, since that's kind of what most people picture when you ask, what is a joint made of? So when you look at joint areas, it's helpful to look at them from this view, from the side. This would be called a sagittal view of the leg. You can see all the fun shapes that joints make around the bones. Obviously they're not just ovals, right? Cushioning all the different edges of the bones. So in green, on the very inside, we have that synovial membrane. The membrane does most of the heavy lifting in terms of generating the synovial fluid, and so it's pretty important in that way. When a joint gets damaged or inflamed, for example, this is the structure that's generating the extra joint fluid that leads to swelling. But the membrane itself isn't strong enough to hold in all the joint fluid safely on its own, so it's reinforced by the capsular ligament, shown in orange there. And that's kind of like the husk that goes around the whole joint, keeping the fluid in and impurities out. It's very fibrous and tough and surrounds the whole joint as well as the synovial membrane. And yeah, there you go. That's those 2 structures explained. They're pretty closely related and they're in full contact with each other. So those are those 2. Then regarding the collateral ligaments, they basically form the outermost layer of a synovial joint. There are medial and lateral collateral ligaments, so 2 per joint. They are short, fibrous, strong, and elastic, keeping that joint from hyperextending side to side. And very importantly, they attach to a little bit of the capsular ligaments themselves, as well as the bones. So they're a part of the joint in that way. And it's good to note that they tend to be perpendicular to the ground, more like straight up and down or vertical. Not really aligned with like the angles of P1, P2, and P3. And next we have the joint fluid itself, or synovial fluid. It's also referred to as joint oil in our textbooks. It primarily reduces the amount of friction in a joint, but it also helps absorb shock. It's made of mostly hyaluronic acid. That's kind of the main thing you can think of. It's the active ingredient in the cosmetic product on the left, as well as lubricin, proteinases, and collagenases. In reality, it's a little complicated on how exactly joint fluid is made, but the main takeaway is that hyaluronic acid is the primary ingredient in joint fluid, and that acid is mostly made by the synovial membrane. So Synovial membrane is also considered a non-Newtonian fluid, which is a science term that basically means that it kind of acts like oobleck, if you've ever played with that. It's normally runny like a liquid under normal forces, but if a high force is suddenly applied, it gets stiff in response. And this is why it helps absorb shock in some ways. But it also helps it perform what is called weeping lubrication, which is when some extra joint fluid that is soaked up into the articular cartilages kind of seeps out under high pressure, like water out of a sponge, keeping the joint lubricated even when the bones are squashed down until they're nearly touching. So it's just a generally cool, interesting substance, this synovial fluid. Has a lot of fun properties. It's also found in tendon sheaths and bursa, for what it's worth, although we aren't going to be talking about the anatomy of those structures today. Just good to know that it is also inside of those. Lastly, we have the articular cartilage. We've talked about it in some other videos, but to recap, it's hyaline cartilage or smooth cartilage that covers the articulating surfaces of the bones in a joint to stop bone-to-bone contact from happening. So it keeps things smooth and cushions the bones. We also know it can soak up joint fluid a little bit to allow for that weeping lubrication process to occur. It can be damaged, as we can see in the picture on the right, actually. You can see a little bit of yellowing in some spots. But severe damage can cause exostoses, which is like bone growth where you wouldn't want bone to grow. Arthritis, all that good stuff. I took this picture on the right at a dissection that Heather Bocheman did, where she showed us all the cool stuff that was wrong with this horse's leg as we were dissecting it, which was awesome. You can see in this picture that the articular cartilage is basically the same color as the bone, but Heather showed us that it was there by scraping it away partially with a scalpel, which was super helpful at the time. I had no idea they were the same color. And yeah, Heather's a great teacher and very knowledgeable, which is why I highly recommend checking out her new online program. It's not like a sponsorship, obviously. I just think Heather has a really cool process, and she has a new program called Study Smart, Test Strong for Farriers, which is an online course that's available now that specifically goes over how to study well and how to perform your best on the exam with a bunch of practice tests as well. So if you get nervous during exams and your mind goes blank, she probably has some tools that you can put in your toolbox to help make your next attempt at the exam successful, provided you studied, of course, which is why you're here, so we know we've got that covered. But if you get the chance and want to do your best to prepare for an exam, I'd recommend checking her program out. And with that, we are ready to review. So that was all. We'll start with some questions. So question number 1, where does synovial fluid come from? You may remember that I said in reality it's a little more complicated than what our textbooks would have us believe, but for the most part, we can say that synovial fluid is generated by the synovial membrane. Great. Which is deeper in the joint, collateral ligaments or capsular ligaments? Well, we know that there's kind of like those 3 layers to the sides of a joint, and the outermost is the collateral ligament, and then we have that attaching to the outside of the capsular ligament, which attaches to the outside of the synovial membrane. So this way to that, to the synovial membrane, and so which is deeper between collateral and capsular? The capsular. Cool. Where else can synovial fluid be found? There were 2 places I kind of snuck in there, if you were paying attention, and they are tendon sheaths and bursa. What structure coats the ends of the bones in a joint? That is a pretty straightforward one. The structure in question is called the articular cartilage. Wonderful. And lastly, does joint fluid belong on your face? Yes or no? If you're dissecting a leg, please don't take joint fluid out of the joints and put it on your face. As we learned in this episode of the series, joint fluid belongs within the synovial membrane and not on your face, despite what the modern cosmetic system would have you believe. And then it's also important to be able to label these. So one more time for the kids in the back. Here, look, bones. That's what those are. Those are bones. This blue stuff is articular cartilage. In the middle, we have synovial fluid. Innermost layer, that's going to be your synovial membrane. Middle layer, that'll be your capsular ligament. Then on the outside there, two, one on each side, will be your collateral ligaments. Wonderful. And with that, we are all finished, not just with the video, but with the Bones and Joints series in general. Yay! That is some serious progress. As it stands, we have now tackled two main categories of topics, hoof structures and bones and joints. So next up, I'm planning to start the Circulatory System Series, starting off with a video on the main structures in the circulatory system that we need to know. Think arteries, capillaries, veins, maybe chuck nerves in there too. And then we'll be talking about like where things are located, talk about AVAs, all that good stuff. So pretty exciting, and I'm thrilled to have come this far. Thank you as always for joining me. Hopefully this was either a good review of synovial joint anatomy or you learned a bunch today. As always, if I made any errors that need to be corrected, feel free to let me know in the comments, or if you have any other feedback, that's always welcome too. Don't forget to subscribe if you want to see more of these videos pop up on your feed and to see new ones when they come along. But for now, thank you. It's been amazing, and I will see you in another video.